Hi everyone. For today's science class, we're going to do something a little bit different. One of the areas of the science exam that's going to be quite new for you is this idea of scientific method. Throughout the exam, you're going to see questions about experiments, about investigations, and you'll have to comment or answer questions about the way that the scientists have planned and conducted these experiments. You'll need to understand the order, the process that people go through. You need to know about the different elements of the investigations, such as independent variable and dependent variable. And you need to be able to find problems or ways to improve the validity of the results. So every Friday, we're going to go through a scientific method course. And the book's going to last about 10 weeks. So today is an introduction to this, and we're going to look at the whole of the scientific method and introduce this with a practical example at the end. Now, I'm not going to tell you what to write down, but throughout this video, there will be many things that are new to you. And so whenever you think you would like to write something down in your exercise book, please just pause the video and write it down. Okay, I'll leave it up to you to decide what you need to write down and how much you need to write down. Now, in science, ideas are developed through a process. The process starts by asking questions, and then people try to guess what the answer will be, and then they have to do an experiment. They have to test if their idea is true or false. In the GED exam, you will be getting questions on the scientific method. That means the different stages involved in finding out information. The formation of a hypothesis, and a hypothesis is a guess or a prediction about what will happen. You'll need to know the difference between dependent and independent variables. And when you read about an experiment, you'll be asked questions to identify what is the independent variable, what is a dependent variable in this investigation. You will also need to make sure that the experiment is reliable. And we'll talk about that in a little bit more detail towards the end. And linked to that is how to improve the experiment. And there will be questions that ask you to calculate results. So yes, math is actually included in the science exam. But don't worry, there's an on-screen calculator that you can use. This first lesson today is going to go through all of these points very briefly. And then the subsequent lessons over the next 9 weeks are going to go into more detail on each of these issues. So the scientific method. There are normally recognized 5 steps in the scientific method. Number 1, the scientist needs to ask a question. Number 2, the scientist needs to collect information. Number 3, the scientist needs to form, to make a hypothesis. And then number 4, the scientist needs to test that hypothesis to see if it is true or not. And finally, the scientist needs to form a conclusion. This is really important and one of the most important things that you're going to see in today's video. So please do make sure you remember these 5 steps and you remember the order that these 5 steps will come in. So let's think about those 5 steps in a little bit more detail. Scientists begin by asking a question. They might look at the world around them. They might see something that they don't understand. They might be puzzled. They might want to know how something began or how something changes. And so when people look around the world, they want to know why something happens the way it happens. It's very important that at this point, the scientist is just asking a question. They're not making a conclusion. They're not making a prediction. They're just asking a question. They are finding an area that they want to know something about. After they ask questions, well, the second stage is to look at what people already know. They need to gather information. When they gather information, they will try to understand the area in more detail. They will look at what people have already discovered, what people have already done experiments to find out. And this information will help them to answer their question or help them to predict how their question should be answered. Predict means to guess. So scientists have a question, they collect information. When they have information, when they have knowledge about the topic, then they need to make a hypothesis. And a hypothesis is a guess, a prediction about what will happen under certain conditions. So if this happens, then this will happen. But it is a guess. It is not knowledge, it is not a law, it's just what the scientist thinks based on what they have seen. Sometimes the hypothesis will be true, sometimes it will be proven to be false. It doesn't matter. Many hypotheses in science are proven to be false. After the scientist has their hypothesis, they need to test it. That's the only way to know if it's true or false. To do this, they will perform an experiment. Now, an experiment is a controlled situation. In an experiment, most things are kept the same, and only one thing that is being investigated is changed. This is called the independent variable. Scientists will also try to measure or to watch something. This effect that they're seeing is called the dependent variable. And to make an experiment stronger, scientists can repeat the experiment many times. And if you're getting numbers, if you're measuring something, then you can average for each time. Finally, the results will be analyzed to see if the hypothesis should be accepted or rejected. So here's an exercise for you. Look at these 5 steps in an investigation. Try to match each of these 5 steps to the correct label in the scientific method. Pause the video now while you try to match these. Okay, now some of these are going to be easier than others. For example, a scientist concludes. Well, if you are concluding, you are making a conclusion. So number 5 is going to be D. This is the last step in this investigation. Another one is a scientist wonders. If you wonder about something, it means you think about something. It means you don't know the answer. You are interested to know what the answer might be. So you are thinking about a topic, you are asking a question. So answer B, a scientist wonders how the mass of an object affects the time it takes to fall. So they're the 2 easy ones. Now we have collecting information, forming a hypothesis, and testing the hypothesis. Well, actually, the last one is also quite easy. The scientist devises a test, makes a test, where he can measure something. So E is going to be testing the hypothesis. A scientist thinks that objects with a larger mass will take more time to fall. This is what they think. This is not what they are collecting from other places. This is what they are thinking. They are guessing. They are predicting. So answer A is going to link to forming a hypothesis. And so the last one, the scientist collects information about air resistance and terminal velocity. This is going to be collecting information. So let's look at this. In this experiment, we're thinking about how does the mass of an object affect the time it takes to fall. The first step is the scientist wonders how the mass of an object affects the time it takes to fall. Notice at this point, the scientist is not saying it will be longer or shorter. The scientist is not trying to guess what will happen. The scientist is just simply looking around and thinking, how does this affect? How does the weight of an object affect the time it takes to fall? Secondly, the scientist will collect information, in this case about air resistance and terminal velocity. Terminal velocity means the maximum speed of an object falling towards the Earth. After the scientist has collected some information, then they are in a situation where they can try to guess what will happen. So the scientist guesses that objects with a larger mass will take more time to fall. After they guess what will happen, they need to test it. So they need to make an experiment. In an experiment, they can measure the rate of falling objects with different masses. And at the end, the scientists conclude that he was wrong. The mass did not affect the speed taken to fall, the time taken to fall. Now, hypotheses. Hypotheses is plural, hypothesis is singular. So a hypothesis is a guess about what will happen based on knowledge related to the topic. A hypothesis must be specific and make a prediction that can be tested. If you cannot test your hypothesis, then it's not a good hypothesis. So, have a go at the exercise below. Pause the video now and decide which of the following is a good hypothesis. So, we know that objects with different surface areas take different times to fall because of wind resistance. For example, a leaf will take more time to fall than an apple. The leaf has a large surface area that the wind will blow against. The apple has a smaller surface area. Therefore, which of the following could be an appropriate hypothesis? The objects with more mass will hit the floor quicker. The mass of an object will affect the speed of fall. Well, the answer is A, because we have the idea of more mass means more quick. B cannot be tested. The mass of an object will affect the speed of a fall. Will affect, but will it make it quicker? Will it make it slower? We cannot test if this is true or not because it's not accurate enough. It's not specific. We don't know how this effect is going to happen. A hypothesis needs to be more detailed. Now, anything that can be changed is called a variable. So in an experiment, there is normally one independent variable. And the independent variable is the thing that the scientist is controlling. There's normally one dependent variable, which is affected by the independent variable. Sometimes this will be a number. This might be a speed or a weight. This is something that will often be measured. So you might get a numerical answer. And then there are also controlled variables, which are kept the same. So controlled variables are kept the same. By only changing one variable, it is possible to link the difference observed to the one change made. So if we only change one thing, then the effect that we can see must be linked to the thing that we changed. But if we were changing many things every time, it would not be possible to know what caused the change. For example, if you're growing seeds and you give different seeds different amounts of sunlight, also different amounts of water, also different locations to grow, then there's three different things. How do you know if it's the location or the light or the water that makes the plant grow better? You simply don't. But if you grow two types of plant, one that has no water, one that has a lot of water, or three types, one that has no water, one that has a little water, one that has a lot of water, and then you measure the amount of growth, well, the amount of growth is going to be the dependent variable, and that must be linked to the amount of water that the plant's got, if that is the only thing that is different. So in that idea, you would make sure that every plant was in the same location and every plant got the same amount of sunlight. So when you're keeping things the same, you are controlling. When you're choosing to change, like how much water the plants get, then this is the independent variable. And what you're measuring, so in that example, measuring the amount of growth, how much the plant grows, then that is the dependent variable. I understand this is quite difficult to get your head around sometimes, but we are going to spend a lot of time over the next 10 weeks looking at independent and dependent variables.
Hi everybody, let's do a science experiment together. Now, how does the mass of an object affect the speed it takes to fall to the floor? For example, let me show you 4 objects. Here is my wallet. Here is correction fluid. Here is a bottle top. And here is a buck. If I drop each of these objects from the same height, which one do you think will hit the floor first? Do you think the buck? Because it's the heaviest, it will fall more quickly. Do you think the eraser? Because it is streamlined, it will go through the air more quickly. What do you think will happen?
So in the exercise on the scientific method, I gave you a situation. We want to ask a question. How does the mass of an object affect the speed that the object will fall? In the video you just watched, I showed you 4 different objects. A buck, a wallet, a correction pen, and a bottle cap. So if I was to drop these things at the same time, which one do you think would hit the floor first? Why do you think that would hit the floor first? Pause the video now while you try to think of your own answer.
So let's weigh each of these objects. If we look at the buck goes on to 21 something or other. I don't know what these things are. These are in Burmese. But you can see that it's on 21. My wallet, let's put this inside. My wallet comes on to 1, 2, 3.5, whatever they are, these Burmese units. The correction fluid, well, the correction fluid is on 1/2 of whatever they are. And the top of the Mima bottle, which I'm sure Thabo was drinking earlier. Well, the top of the Mima bottle does not even change the needle because the weight, the mass of this object is very, very small. So again, I ask you, which of these 4 objects do you think would hit the floor first if we drop them at the same time? Okay, so we're going to try this. We have the buck that's heavy, the wallet, which is less heavy, all the way down to the bottle cap, which is very light. Let's watch together. 1, 2, 3. Did you see which one hit the floor first? They all hit the floor at the same time. Let's try again, because in a good science experiment, you need to repeat the experiment to prove that this is not random. If you only do a science experiment one time, you might be unlucky or you might be lucky. So we need to do the experiment at least 3 times to prove that the result is valid. So let's go again. 1, 2, 3. You see again? They all hit the floor at the same time. Now we did 2 times. But to really make sure that this science experiment is valid, we're going to do it 1 more time. And if we can repeat something 3 times, that suggests that the result is valid. So, 1 more time for my poor wallet to go on the floor. Are you ready? 1, 2, 3. Now you see this time, the wallet and the buck hit the floor before the bottle cap and the ink. Why was that? Well, if you rewind the video a little bit, you will see that we did not release the objects at the same time. This is why we have to repeat a science experiment 3 times. Because one time you can make a mistake. But if you look at the average of the 3 times, we see that on average, all the objects hit the ground at the same time. Even though the last time went a little bit wrong, because there was a mistake in the experiment. So this is an example of why we must repeat the experiment to get a more accurate answer.
So as we've been watching that video, you saw that I weighed each of those objects for you. So you can see the book was very heavy, the wallet was a little bit heavy, the correction pen had almost no weight, and the lightest object was the bottle cap. Now, normally we'd do this a lot more carefully. We would write down the exact weight of each object, and we'd write down the time that the objects take to fall. But as this is just a simple introduction, I just show you from heaviest to least heavy. Now, you saw that we did an experiment. We dropped those objects at the same time, and we watched to see which object hit the floor first. In that experiment, what was the independent variable? What was the dependent variable? And what was the controlled variable? Look at answers A, B, and C, and try to match these 3 names to the 3 variables. Pause the recording now. Okay, so an independent variable is something that the person doing the experiment chooses to change. What did I choose to change? Well, I was choosing to change the mass of the object. I could have chosen 4 pens. I could have chosen 4 pieces of paper. But I chose 1 heavy book, 1 moderately heavy wallet, 1 moderately light correction pen, and 1 very light bottle cap. So I was choosing objects of different mass. So the mass of the object was different, and I was choosing that mass. So the mass of the object is going to be the independent variable. Secondly, what was I watching? Well, if I had a stopwatch, I might be doing the time it takes to hit the floor. Actually, in the video, because I don't have a stopwatch and it's difficult for you to see on the internet, what we actually did was just look at which one hit the floor first. But we are looking at the time it takes for the object to leave the hand and then hit the floor. This is what we're watching for. This is what we're measuring. So the time taken to hit the ground is going to be the dependent variable. Now, every time we did that experiment, we kept the height at the same level. If you look at my hands and Teacher Simai's hands, they were all in a line. We wanted to make sure that the objects were starting at the same position. So the height of the object was controlled. It was kept the same. For reliability, we'll just touch on this now. An experiment is reliable if it is replicated. So replicated means repeated. So if we can do the experiment several times and we get the same results, then the experiment is said to be reliable. Also, if the experiment is done under strict conditions, so you are controlling all the other variables, then it is more reliable. If there's lots of things that are changing every time, then it would not be reliable because there's too many variables. Sometimes, though, you may find that the results do not match what you expected. Think about that video. The first 2 times that we did it, the objects hit the floor at the same time. But the 3rd time we did it, the objects did not hit the floor at the same time. Why not? Well, sometimes you need to look for an error in the experiment. And you saw at the third time in that video, teacher Simai and myself, we let go of the objects at slightly different times. So the objects hit the floor at slightly different times. This is an example of an error, of a mistake. And so when you get one set of results that are different to all of the other sets of results, then you should be looking for any sources of error. Also, you might want to check if your hypothesis is correct or not. You can always reject your hypothesis. You can say you got the hypothesis wrong. It's been proven to be not true. And then you can make a new hypothesis and you can test again. But one thing you can never do, and this does come up quite often, you can never change the results. Once you do the experiment, you get the data from the experiment, you can never change those results. They are the results that you got. If they don't match your hypothesis, there may be a mistake in the investigation, or the hypothesis might not be true. But you never change the results. So, in an experiment dropping objects, the first 2 times all 4 objects hit the ground at the same time. However, in the third time, the 2 objects hit the ground later. Why did this happen? Pause the video and write down now. Well, as we just talked about, there was a mistake in the investigation. The objects were let go at different times. If you use your imagination, you could probably think of other possible answers. Maybe the starting height of the objects was not the same. Maybe there was something in the way, blocking the path to the floor of 1 or 2 of the objects. There are many possible errors, and when you do get results that do not match other results, you must go back and look for any mistakes in that example. And this is why when we do an experiment, we try to repeat the experiment. Doing the experiment one time might not be accurate. If you do it 2 times and you get 2 different results, well, how can you know which one is true? It's not possible. But if you do it 3 times, and 2 times you get the same result, and 1 time you get a different result, then that 1 time that something was different might be because of an error. So repeating the investigation and checking for any source of error is always going to be very important when you're looking at this type of question. Now I'm going to stop the video for today. This was the introduction to the scientific method. Make sure you do know those 5 steps. Make sure you understand what an independent variable is, a dependent variable is, and controlled variables are. And try to have some ideas about how to improve the accuracy of an experiment. Next week, we're going to go into the scientific method in more detail. And I'll hopefully have another short experiment to show you.